You're good to go, sweetie.
Hi, my name is Simon, and I am talking about Bernoulli's principle.
Bernoulli? That's a mouthful. That's a tricky word. What does Bernoulli mean?
I forget.
You forget?
Oh, wait. It's the last name.
Oh, yeah. It's the last name of somebody. And what's Bernoulli famous for?
Because he worked on fluid mechanics?
He did work on fluid mechanics. We already have some friends watching. We have Leslie and her crew. We have Parker watching.
Camille.
Yeah, we have Auntie Camille, so that means Connor and Logan and Iris are watching. We have Casey. Guess whose birthday it was yesterday?
Who?
Iris. So a big happy birthday to Iris, who's now 3. All right. So you said Bernoulli worked on fluid dynamics? Is that what you said? Yeah. When was he born?
1700.
Yeah, so this is quite a long time ago. And wait, hang on. Let's see this. Can you tell me a little bit about what he did?
He worked on dynamics, which was the basis for airplane wings before airplanes were even invented.
Oh, that's pretty cool. So how does that work then? If you have an airplane wing, what is part of Bernoulli's principle?
This.
Yeah, so tell me what that means.
Fast air on top and lower on the bottom, and fast air equals low pressure, and slow air equals high pressure, and those two, and plus those two together makes the airplane able to fly.
Okay, so can you show me which one of your hands was the fast air on the top? And that creates an area of low pressure on the top. And show me which was the slow one. That's some pretty slow airflow. Pretty good. And that creates an area of?
High pressure?
Yeah, high pressure.
But I don't know how that works.
Well, it's the difference between the low pressure and the high pressure. And that high pressure is pushing up the other air, so it creates...
Pressure?
It creates...
Lift.
Yeah, you're right. It creates lift. There we go.
Egg.
Egg? All right, so you've got something over here that I can see, and it looks like a plastic bag. What's that plastic bag for? Oh, look, Matthew and Grace, all the way from Cranberry Portage, are watching. Reed's watching here in Winnipeg. This is amazing. Okay, so what's the plastic bag for? You have a demonstration here all about Bernoulli's principle. Can you explain what you're doing?
I'm blowing up a bag.
Okay, so let's try this again. We want to show our friends something. This is just a regular, ordinary, old plastic bag.
That's crumpled.
Yeah, that's crumpled. And we had to make sure that it had no...
HOLES.
That's right, no holes in it. So we're taking out all the air. And I'm going to show you something here. I'm just making a little opening with my hand there to see if we can get all the air in Simon's lungs into the bag and see how much. Okay, so look at that.
That.
We captured that much air. You've got some pretty good lungs. Now let's see what happens if we do it just a little bit differently. If we do this a little bit differently, then I'm going to make this opening just a real slight bit bigger, and Simon's going to blow into the bag from a little bit farther away. And let's see how much air we can capture. Whoa, look at that. Now it's almost the full bag. So why did that happen, Simon?
Because my breath that was going in attracted other air molecules that were already hanging out around in the open space.
That's right. So you had air from your mouth going in, and that fast air pressure captured all the other air around you. So you were actually able to blow this up even faster.
Or relaxing floating air molecules.
Relaxing floating air molecules. Decided not to relax anymore. Pretty cool. We have Lucy watching. We have Parker and Wendy watching. We have lots of friends watching. So hello to everybody. So I'm going to flip this camera around because you, Simon, have something over here. What's that?
Paper airplanes and my face.
Yeah. What are we going to do with those paper airplanes?
Throw them.
And see what?
See this.
Okay. So we're going to test each airplane. How many times?
3 times.
And what are you testing them for? What are you measuring?
Flight.
Yeah. We're going to measure the distance that they fly. All right. So let's go. Take your 3 airplanes and let's go over to our flight area.
This is my favorite one.
How come that's your favorite one?
Because I named it Big Boy.
That's pretty funny. Okay, grab all 3 that you want to test. And we'll go over to our flight zone here. Now, we have set up a space right here for Simon to stand so that he's in the same spot to start all the time. And then we also have something here, Simon. A blue shoe?
My mom's shoe.
Why are we using a shoe?
To measure the distance my airplane flew.
That's right. We're going to use the shoe to measure. It's called a non-standard unit of measurement. And that's what we'll use to measure how far the airplanes are going. So let's start with plane number 1. I'm going to go to my spot way back here. This is our flight path.
Okay.
Simon, you can stand in your spot. And I've got the paper here to record what we find out. So that plane looks a little bit short. That's a neat design.
I named him Fat Big Boy. He's not short, he's tall.
Oh, cool.
He's tall and short.
Okay, let's see. Whoa. Okay, use your shoe to measure. How far did it go?
It was 1.
1 shoe? Yeah, it didn't go very far. So plane number 1, 1 shoe. Okay, go ahead. Try it again. Okay, try. Or do your measurements, sweetie.
1, 2, 3, 4, 5.
5 shoes?
5.
All right, good. So trial number 2 had 5 shoes. Again, we're using shoes just in case you don't have any tape measures. You can use something different to measure what you're doing.
Garbage bag.
Okay, go ahead, Simon. Ooh, that was a cool landing. Okay, use the shoe to measure.
1, 2, 3. Okay, I'm going to go all
Okay.
around. I'm going to cross the street.
Okay. 4.5. Okay, here we go. What are you going to show, Simon? You want to show them something? Go ahead.
Just if you didn't see, this is how the airplane landed.
Pretty cool. I like it. Okay, so now we're going to test plane number 2.
And I got something to tell you.
What is that?
The on Instagram, this one had 2 zeros.
That's right, because it kind of looped around and flew backwards.
Yeah.
Whoa, that was a good one.
Not as bad as the rest.
Yeah. While you're measuring, Jackson says hello.
2, 3, 4, 5, 6 and 1/4.
6 1/4. That's pretty good. Okay, try that plane again.
I think I should be just 2.
Just 2.
Yeah. And it's not right there.
Oh. Oh. Is that a 0 or do you want to try it again?
Okay, I'll count that.
You'll count that one? Yeah, because it kind of did it twice.
1.
1 shoe. Okay, and third trial for this one.
Seriously?
Seriously. Is that a mistrial?
You're grounded.
Literally grounded. Get it? Airplane. Grounded. Okay, do you want to count that one?
1.
1 shoe?
No, 2.
2. Well, do it carefully.
It was 2.
Okay. So there we go. That one didn't do so well. Okay, now try your favorite plane.
Still better than the last one.
Yeah, that's true.
Still better.
Now, why is this your favorite plane?
Because I named it Big Boy.
Cool.
And why I like it because I named it Big Boy is because it's spelled boy wrong. I did B-O-I.
Oh, that's a funny way to spell boy.
Because I did it like boil. And boil is spelled B-O-I-L.
Yeah.
So then I spelled boy that way.
Cool. Okay, let's try this one. Ready? Okay, go for it.
Sit. Fire.
Whoa, it went past me and around the corner here. Okay, you're gonna have to use your non-standard unit of measurement, also known as
Shoe.
mom shoe.
1, 2,
Oh, whoa, 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 you got ahead of yourself there. Okay, start with 1, let's count together. 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sword paper. 13.
hang on, I'm in the way here. Go ahead.
13. 14. 14.
14 mom shoes. Now we had a prediction from Parker who had guessed 4. Let's do this one again and let's see what everyone's predictions are for Simon's favorite plane, Big Boy. Okay, grab the plane. Let's try number 2.
2. 2. 2. 2. 2. 2.
Okay, so let's see. Hang on. Everyone in the audience, what is your prediction? How many mom shoes will this plane go this time? Oh, Casey's guessing 10. While everyone gets in their prediction, do you want to tell people what a prediction is?
A prediction is when you guess something but you don't know for sure.
That's right. Camille is guessing 16. Clarissa is guessing 5. Jackson says 16. Parker says 10. All right, let's test this out.
I think the closest ones will be the people who guess 16.
Is that your prediction, Simon? 16? Cool.
No, like around there.
Around there. Okay, let's try it out.
Like, I think it's like either 11 or above.
All right. Ready? Whoa! You got me right in my leg.
How does it bounce back?
I think, yeah, it bounced back, but it actually hit me in my leg. So do you want to measure to my leg or do you want to count that as a mistrial?
I'll do it to your leg.
Okay.
1, 2, 3, 4.
Matthew says 14. Grace says 10. Miss Kelly says 13.
9.
And Camille's asking, what's the
10,
prize?
11. 11.
Well, no, we're counting it all the way to where it hit me in my knee.
11. 12. 13. 14.
Yeah, 14. So it tied, and which is about right because when it was over there, that was 14, and my knee is pretty much in the same lineup. 14 again. Good one. Are you going to answer Camille? Camille wants to know what the prize is if they guess it right.
The prize is no prize.
Oh, that's a wonderful prize. Okay, last one. Let's try this plane one more time.
Come on, boy. Don't fail me now.
Okay, Casey's guessing 31.
Don't mind your big belly, boy.
Hang on. We're going to let people get in their guesses. Let's guessing for this one. But you know what? I'm going to move out of the way because I don't want to wreck the results for this. Camille's guessing 16 again.
9, 8, 7, 6,
Go for it. Whoa, all the way as far as it could go. Okay, grab that shoe.
14.
Oh, because you left it on 14.
15. 16. And I think a quarter.
Well, so it wouldn't be quite 16. It would probably be 15.
No, it's 16 and 1/4.
Okay, let's put that down. Look at that. So here's our results.
Good boy, good boy, good boy.
And
good big boy.
yeah,
Big boy.
Big Boy won by far. And that means Big Boy has what?
Has the best dynamic.
You're right. It has the best fluid dynamics. And it created the most difference between the air pressure between the top of its wings and the bottom of its wings.
Because of the point.
Let's see. Yeah, there's a lot of different variables that we could talk about when we're talking about airplanes. Simon, you had some other ideas for what we could test next time.
Can it fly in a show?
Well, that's one test. What's another test?
I'm gonna test it right now. No, it cannot. Well, they're still the same.
Okay. What are some other things that we could test for variables?
How far or what direction would it turn if we made the wings uneven?
Yeah, that's a good one. Anything else?
Yeah.
I have an idea. What if you put weight on it, like a penny or something, if that would change how it flies?
I know.
What else could we test?
Can you fly it on ground like this? How far would it go if you do this?
Oh, as opposed to air, you're letting it glide along something solid. All right. So, Simon, can you explain to everybody what our challenge is for today?
Do the thing that I just did.
Well, what's the thing you just did?
Before that, and when I threw this shoe with the toy.
Okay. So we want to see if people can create 3 paper airplane designs, test each design at least 3 times because we want to see how good the flights are. Measure it with a non-standard unit of measure. If you're really good at this and you really want to challenge, you can test it more than 3 times and create the average and find out your average. All right, Simon, is there anything else you would like to say?
Yeah.
What's that?
Why are my hiccups gone?
Yeah, Simon's been having hiccups all morning and now they're finally gone?
Yeah.
All right. So, folks, we'll see you again Wednesday morning back to our regular time at 11 a.m. See you then.